Good morning. I'm going to try not to pace around too much so I don't fall off the back of the stage. Watch out behind you if I start moving too much or something. I'm going to talk about machine learning. Sandro said to me, I'm not sure what machine learning's got to do with it, or IT, or indeed anything. So let's find out. Need to start by asking, what is machine learning? Anyone using any machine learning techniques? A few. It's becoming really popular at the moment. I've noticed a trend recently where people are starting to call it AI instead, whatever it is. People tend to say machine learning is machines learning from data. That's a phrase that I'm hearing bandied around a lot recently. I'm not sure that's true. We'll come to that in a moment. What about data science? Any data scientists in the room? Anyone working with any data scientists? Do they test their code? That's a different talk. We'll get round to that. Maybe machine learning is part of AI, so a broader church. I beg some other questions, like, can machines actually learn? People who are doing machine learning, what has your machine learnt? No? Can machines be creative? Perhaps learning and intelligence involves some creativity. So, can machines be creative? Lots of questions. Not sure we're going to get many answers this morning, but that's okay, right? Let's do some history lessons. We've had some of those, and we should learn from history. Like, as I said, at the moment, people are describing machine learning as machines learning from data. If you look back to the origins of the word, a guy called Arthur Samuel coined the term a long time ago now. What he was doing was trying to teach computers to play games. He started with drafts or checkers, depending on which side of the pond you're from. The idea being, instead of explicitly programming it procedurally to see what the different states were, and you could do the same with tic-tac-toe. You can work out the states and then brute force what might happen. So tic-tac-toe is a bit simpler. You've got quite a few states there. When you do drafts, chess, go, But his idea was, well, instead of trying to explicitly program to solve one problem, could we just tell it the rules and then give a scoring function? You win, or you lose. And then let it have another go, and then let it have another go. So we've got a scoring function going on, which, if you've got a game, you've usually got someone wins, someone loses, so that works immediately. And just let it try several times and see what happens. Now, in order to make that work, you can't do a procedural deterministic thing. You need some non-determinism. We saw some of that just now with the Petri nets. Or if you just do something random, toss a coin to decide whether you're going to go here or here, then maybe the machine can learn. If it can learn to play a game, then it can learn to do, well, not necessarily anything, but maybe play some other games. So the machine learning was about trying to get the machines to learn. It wasn't about analysing data and doing statistics originally. So when people tell you machine learning is all about learning from data, no, historically it wasn't. We were trying to teach machines to learn as it played games. And in general, machine learning is not necessarily about learning from data. If you look under the hood of lots of the machine learning frameworks, there's something random going on, which may or may not be significant. I think that's quite an interesting train of thought. Sometimes machine learning does involve analysing data. You can start finding anomalies, strange things, things that are unexpected, or possible credit risks if you're trying to loan someone some money, or maybe a warning if all your CPUs max out or something, that something bad's about to happen. And also see what's happening normally as well. Some of it's statistics, some of it's machine learning. Bit of a blurry line there. So, well, we can do some statistics or machine learning on some of our code. Adam Thornhill got a shout out. It was either in one of the talks at the panel yesterday. So I've got loads of people who spoke yesterday have said things I'm going to say today. So I'm going to be doing executive summary of parts of yesterday. Adam Tornill's gone on to write another book, which I've not read yet, but goes into more detail on this. If you're using version control, make sure your data scientists are using version control. And if you've got some bug reports, if you've got some tests running, you've got some data already. Any of you had a look through that kind of data, seen which source files got the most churn, who touched this file last? You can draw all kinds of diagrams or look at patterns and find some pain points in your code base if you start analysing the data you've got on that. If you've not tried doing that, just look up your code as a crime scene or anything that Adam Thornhill's been writing about, and you can learn loads about your code base this way. It doesn't necessarily make you an expert in machine learning or a data scientist, but it might show you something you hadn't noticed before if you start thinking about the data you've got. So I'm just going to leave that one with you. Go away, try it out. Amazing things in there to discover. So still, we don't know what machine learning really is. If we go back and think about different beginnings of AI, some people had the idea that if you built a brain, it would start thinking. So if you've come across neural networks, that's pulling on the idea of building a brain, but instead of a hardware brain or a robot, you're trying to build a brain in software. And then you start thinking, and then you'll have intelligent machines, and then everything will be wonderful or terrible, depending on what kind of sci-fi you're into. I mean, unanswered questions. So a lot of current research and people trying to use AI in all the trendy startups are using what's called deep learning, which is a specific kind of neural network. And a common thing is categorizing things in pictures, tagging things. And there's a recurrent joke about AI is just being used to spot cats in pictures, or possibly dogs, work out which is which. If you look at how a child learns, you can give them 1 or 2 pictures of each, and they get the hang and be able to generalize. If you look at the amount of training data that deep learning ends up needing, it tends to be several thousand images per class. So these artificial brains are learning in a very different way to us. Well, that's okay. We all learn differently. What has this neural network actually learnt? Has it learnt anything? Well, some of these systems get 100% accuracy. They really do seem to work. Maybe it's learnt, maybe it hasn't. You can get yourself into all kinds of problems here because some of the systems that are learning from data, we give them the data. If I gave them data on the demographics of everyone in the room, there might be some AI and machine learning systems that would conclude that there's very few women around, so basically we should just give tickets to this conference to guys. If you feed these systems data about what we're doing now, you might see all kinds of strange bias going on. And did I mention anyone work with some data scientists? Have you got them to try out their machine learning systems with different inputs and see what happens? Or indeed, try the same thing twice on the same input and see if they get the same results or similar results. Can you take, as Arthur Samuel's dream was, one system you've built that's quite good at playing tic-tac-toe and make it play checkers? Can it then learn to play chess? So, lots of questions here. As I said, have the machines learnt anything? Can you reproduce the results? How do you test this? How do you deploy your machine learning systems? Anyone trying to do some kind of DevOps pipeline involving machine learning? Ooh, tumbleweed. Yes, that's a conversation we need to be having. Oh, steady on. So I said, how do we know if the machine's learnt anything? Just a moment. How do you know when you've learnt something? So something I do is try and give talks on it, and then I'll go, actually, no, I don't quite get that bit, or explain it to someone else. That's one way. But I've still always had this nagging doubt of, I don't think I quite understand this properly, and I think we all do that. If I'm going to ask, has a computer learnt anything? I need to think about, have I learnt anything? What does learning mean? How do we learn? I think part of the craft movement, and there's several hints in Agile as well, are talking about some of these. It's not so much soft skills, but the whole process, the thinking, the getting better, the improving. So anyone come across, I'm going to pronounce it wrong, Shuhari before? So I've seen now, at least one hand, so great. The idea is embracing the kata, and it comes from martial arts, and I think a lot of Agile stuff pulls from some martial arts ideas, because there's some good ideas here. It's the idea that to begin with, you just go through the moves. I was about to do a martial arts kata, but I'll remind me not to fall off the stage, so I'll stay still. You follow the instructions, you just do the set moves, and you go through them for years and years and years, and eventually you just know them like that, get muscle memory on it, you're exactly following the instructions. The next level up, you go, oh, hang on, why am I doing that at that point rather than that? What happens if I do this? And you start to bend the rules a bit. You start understanding why you're doing this. And get more to a kind of meta level of principles and things. And then eventually you get to a point where you just know the rules. And then you can really break the rules and make up new rules and create new things. So a learning process there, which is about doing something over and over, seeing how you're doing. Maybe you need a mentor showing you. Now, if you look at a history of craftsmanship in more Western traditions, you've often got someone teaching you as an apprentice and giving you some feedback, and you practice and become more skillful. Just throw in part of the software craftsmanship manifesto there, just emphasising on aiming for well-crafted code, steadily adding values, a community of professionals, and productive partnerships. So could a machine embrace these principles as well? We'll see. So craft about making things. Can AI be creative? That might mean that the machines are sentient or intelligent or learning or something like that. There's a trajectory. Again, if we go back through history, some early things involving computers were helping humans do things. So you've got the beginnings of CAD, computer-aided design, coming out of some tools called, for example, Sketchpad from a long time ago. So that's computers helping us be creative. And at the other extreme, you've got John McCarthy, heard of? Okay. Lisp, invented for a reason. Setting up that artificial intelligence laboratory. Again, like I said, trying to simulate, emulate human intelligence, maybe by building a brain or creating a programming language that can change itself on the fly as it goes, and then we might end up Skynet or goodness knows. So we've gone from augmentation helping to automation. And then you've got somewhere in the middle with people doing crazy stuff with weird music, using technology that was invented to make replicas, to make originals. The computers have been involved in the creative space loads, but often in a way of giving us new ways of doing things. Maybe that's making us more intelligent or learn things. Whilst I was preparing this talk, I fell across quite an interesting blog on Medium about creative AI, and it's talking about a possible imminent future of AI characters and artificial musicians, journalists, bots, and so on. And the perennial question again, but Philip K. Dick, do androids dream of electric sheep? We dream. Can computers dream? Have you got dreams? What is a dream? Are you a replicant anyway? Well, that's a different question. So the spectrum between augmentation and automation, I think, is what's going on with a lot of machine learning and AI. I don't think that the AI is actually intelligent most of the time. It could be, but that might be another discussion, but we're not there yet. And machine learning, I don't think the machines have actually learned, but we're using the machines to do things. And sometimes they're augmenting stuff, helping us out. Maybe we've set up dashboards and we're learning from our own data and going, well, that's interesting. Or we're seeing bias in what's going on when the AI and the machines start replicating what we're doing. Anyone seen a recent incident of a big tech company that the AI started throwing out women's CVs? Any mention of woman? Not interested. Because it was automating their current demographic and going, all right, fine, I'll replicate what you're doing at the moment. You might not want to automate what you're doing at the moment if what you're doing at the moment isn't quite what you really want. So think on that spectrum. And you need to do that anyway, even if you're not doing machine learning. Can I augment what I'm doing? Have some scripts? Or do I want to completely automate it? Think about the purpose, the reason, what problem you're trying to solve. So, okay, quick one. If we want to automate everything, really, that means we could get AI to replace programmers, yes? Maybe? So, a lot of times people go for a job interview and are asked to do the FizzBuzz kata. All know the FizzBuzz kata? Yeah. So you can get the machine to code FizzBuzz automatically, but there's some caveats and things you need in place here. I had a go at this. I used something called genetic programming, which is a variant on genetic algorithms. So a genetic algorithm basically gives you a list of numbers or strings or booleans back that solves a problem. It makes them up randomly, tests them, takes a few of the better ones, and then mashes them up somehow to make a new array. And then maybe it tweaks values. If you've got booleans, you might flip one of the bits. It's doing that because there isn't time to try every possible move in tic-tac-toe, let alone checkers or chess or so on. But it's then exploring quite a few things, and it might well find the winning move or a set of numbers or some strings to spew out in the chat bot to communicate and pretend it's human. I've written about these. Everyone was plugging in books yesterday, so I've written a book as well. Instead of showing you how to use a framework, I'll just show you how to build your own genetic algorithms and several other machine learning and AI tools. I think it's interesting to know how things work under the hood. Can't stop myself. I wanted to give it a shorter title, Can You Code Your Way Out of a Paper Bag? And all the examples involve paper bags and things getting out of the paper bag, and the final chapter brings closure and shows you how to get back into a paper bag. But it allows you to explore some of these techniques if you're interested. So genetic algorithms are taking the idea of evolution. So you have things crossing over, which is like things mating to make new solutions. And every now and again, that mutation. And this is what machine learning's got to do with it. It's part of what machine learning's got to do with it. Evolution is driven by a feedback mechanism caused by the success or otherwise in surviving and reproducing. Modifications of behavior over a lifetime in response to experience. So, just a little diagram of what we're doing. So maybe you've got an array of numbers, or booleans, noughts or ones, and maybe you take part of one, so the first 3 of one and the next 2 of the other, and you've got a new array. And then maybe, like I said, you flip one of the bits. Instead of doing an array, remember we're trying to do FizzBuzz, see if we can make ourselves all unemployed by the AI taking our jobs because it can do FizzBuzz for us. Instead of doing an array, do a tree structure instead. And you can still take a bit of the tree from one tree and combine it with another one, mutate things. Instead of a plus, put a minus in. Instead of 11, put 10, and so on. As soon as you've got a tree structure, you've got a program. If it's a compiled language, it might not compile. If it's a dynamic language, it might all crash in a heap, but then they get rejected. And the ones that work are accepted, and you try some more in a loop, and you have some feedback in there. So we talked about feedback loops, and I think machine learning is all about feedback loops as well. It's exactly what it's got to do with it. You can use this for more than just generating programs and making us all unemployed. You can design circuit boards with it, and you can do some scheduling algorithms. There's all kinds of things you can use this for. The guy who wrote about it originally is someone called Codurance. So there's some pictures of book covers there. They're quite big, but go explore. So, iteration, a loop, and need some feedback, which means you need some tests. So for the genetic programming, we need some tests. And I couldn't manage to work out how to set up the test for FizzBuzz up front without actually writing FizzBuzz myself. That's the hardest part of FizzBuzz, is getting the tests right. So I cheated and borrowed Kevlin Henni's tests. Thank you, Kevlin. So we've got 8 tests, and after much discussion, I've convinced myself they're necessary and sufficient. So if the machine can get all 8 of these to pass, it will generate the code for FizzBuzz. So tests of feedback for the machine learning. And actually, tests of feedback for so much us as well. Tests are important. I used a framework in Python to do this. I had to explicitly tell it which functions it could use, and some tooling for genetic programming will actually just hook straight into the language. So there was a lot of setup. I had to choose how many trees it randomly made, how often it recombined things, how often it mutated things, and it keeps track of a hall of fame, as it calls it. It took me several days to get it to generate the code. So the good news is that actually it's probably more efficient if you just got me to write FizzBuzz from scratch rather than getting the machine to generate the code for it. Do you want to see what it did? In the 8 tests that were the feedback in the loop, I didn't say anything about neat code. I didn't say anything about redundant code paths. Each time I look at this, there's things like either buzz or buzz. And you're like, what have you done? Well, it did exactly what I told it to do, so it serves me right, frankly. So, yes. Yuck. But, however, that was a lot of work to get it set up in the first place. But machines can program themselves. Enough of the Hall of Fame or the Hoff for those of us who are as old as me. So writing tests is hard. I cheated and got Kevlin to help me. But in craftsmanship and in machine learning and AI, the tests are vital. Hard to write sometimes. And forming a necessary and sufficient set up front is a major challenge. There's some talk in the AI community about human in the loop. It's an old idea, but it's becoming prevalent now, where instead of designing everything up front, you actually just incrementally try a bit, and then the human goes, oh, actually, I want to change the test or the target or the fitness function, whatever you call it. Rather, it's more like that, or I'm not sure where this is going. So actually, like, another feedback rather than just all the tests up front, get on with it, make it so. Degree of collaboration and partnership there. Oh, okay. The quote I gave earlier on about evolution and feedback systems, and there was more talk about feedback systems this morning. See, there's themes emerging at this conference. It's great. This guy called Norbert Wiener, who was involved in writing about AI. I said earlier, there's a lot of people talking about building a brain and seeing if it thinks versus kind of general purpose algorithms. And I think we've forgotten about Norbert Wiener. He says, all intelligent behavior is the result of feedback mechanisms. that could be simulated by machines and was an important step towards AI. We've kind of forgotten about him. Some of the stuff about the systems that were being built then, the electronics, aren't quite so pertinent now, but he said lots of really important things. And instead of on the usual hard, soft AI, robots versus software, he took it off in a different trajectory and coined the phrase, I think, cybernetics, or played with it anyway. If anyone's ever fallen across stochastic calculus, he did a lot of things to do with random walks, and you often see DW in some finance applications, and that's Wiener himself. And yes, of course, we know Kubernetes, or however we're going to pronounce it, pulling on the same word, the idea of steering things. And also I mentioned about being able to deploy some of your machine learning stuff and that being really, really awkward, but that's another discussion for another day. Cybernetics, look it up. So, again, but I mentioned this Medium blog, which is really worth taking a look at if you're interested. It's talking about cybernetics being about control in complex systems that needs to be conversational, which is part of what feedback's about, isn't it? It requires not just action, but also listening and adaptation. To steer a boat across the lake, you have to use your tiller and sails to adjust to changing winds and currents. So you've got a feedback bit there. The cybernetic model of control is circular. That's the loop bit. Decisions depend not only on how well people carry out their intentions, but how the environment responds. So we've got the feedback and loops, feedback and iteration. So machine learning's got loads to do with craftsmanship. Loads and loads of really great blogs on the Codurance website. For example, in craft, there's a constant sensory feedback through touch, sight, feel, or a combination of those. It's about a constant evolution of the desired outcome, according to our changing understanding of the material and the desired outcome. Evolution there as well, and I talked about evolutionary algorithms and genetic algorithms. All of the stuff about AI and computers and how to code well, it's all really similar ideas going on if you think about it. So AI, machine learning and craft are about feedback and the feedback loops as well. So it gave a brief overview of genetic algorithms previously. Actually, loads and loads and loads of machine learning and AI algorithms, kind of, that's what they're doing. You've got your loop, and I said earlier, in order to play checkers or drafts, instead of programming precisely what to do, you just let it try something at random. You might bake in a heuristic and tend to go left, or always play more aggressively. If you want, you don't have to. But if you think you know something that helps, steer it slightly, steering, cybernetics in there, and then test them. That's the feedback bit, and tests are important. I said that, didn't I? I'll say it again, tests are important. If you don't see what your machine learning's doing, if you don't test what your AI is doing, if you don't test what your code's doing, if you don't sit back and test yourself, see how you're doing, then you're just doing a random walk which might not help. Remember the better things. Learn from the experience. I don't know, perhaps the machines are learning the same way we do. Similar. Test everything. Hold on to what is good. So, I said AI models often learn for fitness functions, which are just the same as tests or a scoring function. Or maybe you say yes or no. So you need to decide what success or failure means in AI, machine learning, and when you're developing code. Have you got a good idea of what success would look like if you're trying to develop a new feature or a new product? We have loads of conversations about what done means and when you're really done. But what's your purpose? What are you trying to achieve? Is it any good? Is it good enough? Could you do better? Is it okay to fail and iterate and try again? It should be. It should be. Failure is an option. if at first you don't succeed, try again. And actually, if we're learning stuff, if at first you do succeed, try again anyway. Do a code kata over and over. Or if you've made something once, sometimes it is worth going, okay, well, let's try it again. You know? Do we know what success means for AI and as we're writing code, developing products, talking to our customers? And actually, something that's very important in some AI models and machine learning models is to not only allow failure, but embrace it and encourage it. There's a technique called simulated annealing, which instead of just always going to what looks like the next best step, you go, actually, I'm going to go off in the opposite direction, just this once. And then sometimes, instead of getting stuck in a dip somewhere, no, I'm going the wrong way, just one step. You find another place that's even better. Sometimes failure helps you learn and opens up new possibilities and helps you solve problems better. So, okay, skirted round machine learning and AI, not defined anything properly, but it's very amorphous and is a collection of different ideas. But there's the feedback loops and the testing that are really important, and having an idea of what you're trying to achieve here, what does success mean, which is important for what we do, I'm sure of it. But now we can flip it on the head and go, okay, suppose I don't want to be a data scientist or build an AI of some description. As developers, we can still borrow some parts from AI and machine learning to make our code better, particularly in the area of testing. Did I mention tests? I reckon are really, really important. So let's have a few ideas here. Anyone come across mutation testing? A few hands. If you haven't, try it out. It's really cool. I mentioned earlier when I was talking about genetic algorithms, you mutate something once in a while, you change things, and then that in evolution brings about a whole new species, possibly. So it could be a good thing. Now, if you've got some tests, you can measure things like coverage and go, yay, all the code's got tests. But that's not telling you how good the tests are. There's another whole conversation to be had about requirements coverage, and that's a different discussion that I'll leave other people to have. Suppose, now I talked about genetic programming and changing a plus sign for a minus sign. Have you ever done that with a code base? You've looked at a less than equal sign and gone, really? I'm just going to change it to a less than sign. And then all the tests still pass, and you go, yeah, that looks better. That's all right. Have you refactored it then? Or have you mutated the source code? And are you sure that was a success? That was a good thing? Or did you go, ooh, why did no tests fail? I've created a mutant monster. Perhaps I'd better do something about this. Now, you could do that manually, but there's some tooling that'll do it automatically for you in a variety of different languages. I've used Cosmic Ray in Python a bit, and that's really good if you use Python. There's other tooling available for other languages. I've seen a recent talk about C++, and the last was actually just using grep to find certain things and do stuff like less than equal and changing it to less than. So you don't necessarily need frameworks or tools to do this stuff. Just try this, change some of the code at random, mutate it, and if all the tests still pass, that's telling you something. Might well have covered each branch in your code, or maybe someone forgot an assert at the end of the test. Who's seen tests in the test suite that haven't got asserts in? Yeah, I wonder what we're doing there. We're striving for this metric of coverage. Bosh, tick the box, but no, look at it differently. Like, yeah, that'll flush these out. It doesn't always work. I said about swapping pluses and minuses. If you've got a test that sees everything sums to 0, if you swap a plus for a minus, it'll still sum to 0. So it's not going to get everything, but it'll just give you some ideas and you might learn something. That's just from doing something slightly random. A lot of the more hardcore tooling is using the abstract syntax tree, so it's pulling on some ideas from the genetic programming. Instead of generating the code, it's trashing your code just to see if your tests spot what's happened. That's one. Another one, property-based testing. Anyone? Some, not quite as many as the mutation testing. I think it originally started as quick check in Haskell. A lot of AI stuff has got connections with functional languages. History's repeating itself. Things from 60 years ago coming to the fore now. How many times have you seen a test with a magic number that's got a date in, someone's picked their birthday, or a string in that's usually foo or bar or something with some kind of military connection, and many of us have forgotten what the words mean? What? Is it okay if you've just got one? Okay, you've got the code coverage because you sent in your birthday through here. And maybe you've then sent in a specific leap year or something. Could you test every date ever that's representable on your computer? Would there be any point? Could you just pick out a few? Like I said with genetic algorithms earlier, you're picking a few things, and then it can zone in on areas of interest. So you tell it what property you want to hold. If you can remember the FizzBuzz tests I nicked off Kevlin Henney, they were kind of 8 properties. Either a fizz, a buzz, a FizzBuzz, or a number. That's quite general purpose. And a property-based testing approach will generate inputs and see if your properties still hold. And it'll report back if it's found some inputs that don't hold, that make those kind of more general purpose tests fail. So if you spot some tests with some magic numbers in where someone's got their favourite string they always use, like hello or a birthday or 42 as an input number, or 101 or 9999, whatever people use, start looking at property-based testing. It will generate stuff for you and report back if something fails. And a lot of these are tending to use variants of genetic algorithms to guide in and find where things go wrong. So if you start learning about how they work, that's really interesting as well. If you're interested, maybe that's just me, who knows. Or more generally, come across the idea of fuzzers before? So instead of like finding inputs for specific functions inside your code, like white box testing, just chucking stuff at the whole system from the outside. Now, some of them are just doing loads and loads and loads and loads of random stuff, which is cool because doing loads of random stuff, you can still learn from that, actually. Or some of them are doing a bit more targeted, aiming for inputs that crash the system. And people have found vulnerabilities. There was some talk about some security tooling in OWASP the other day. So go away and look at that as well. But test your code in loads and loads of different ways. See if you can work out how to break it. Loads of this, just trying something at random, changing something, seeing what happens. Which is kind of how many machine learning algorithms work. And actually, I think that's how many of us do learn as well. There's some similarities. So, I asked the question, what's machine learning got to do with it? Well, in terms of what it's got to do with craft and becoming better programmers, it's about feedback and iteration. So, just one final thought. I've talked about tests as feedback. I don't think we've 100% defined feedback yet. We've skirted around the edges of it. We've skirted around the edge of what machine learning means, what AI means, what craft means, what anything means, what mean means. That's a different question. So, quote from Kevlin, why not? If you want someone to learn, or indeed a machine to learn, create the opportunity and environment for them to discuss and contribute. Otherwise, the feedback becomes more about the person giving the feedback than the person receiving it. Feedback should have purpose and it should enable purpose. Oh, we talked about having the wrong metrics, and then the wrong thing starts happening. Think about what success means. Think about what you're trying to achieve. See if you're achieving it or not. That human in the loop, actually don't just set off the machine and then end up with Skynet and some dystopian future. Collaborate, be involved with what the machines are doing, and your colleagues, and your data scientists, and So, okay, we had some bits from the craftsmanship manifesto earlier on. Talked about well-crafted software. You saw the code, the genetic programming evolved, didn't you? Yeah, I'm not sure that was well-crafted. But that's okay, and we didn't put in the test, oh, by the way, I don't want redundant branches in my code. If the machines do generate the code for us, we won't ever have to look at it. So it doesn't matter then, does it? Or does it? I don't know. Discussion point for you. How do we steadily add value? Well, we need that feedback, and you need to iterate. You don't just do it once, release, done. You need to try again, even if you're succeeding and winning. Can we make this better? Can we make this different? Could we make it do something else? Okay, we've built this system that plays tic-tac-toe. Can we now play drafts? What about chess? What about Go? Building up a community of professionals. What happens if you get two chatbots to talk to each other? That's another story. Some of you might have come across that sort of conversation. But can we collaborate with the machines? Can we collaborate with each other? Yes, we can. How do you have a productive partnership with AI or machine learning? Well, yeah, you need some humans in the loop. And you need some humans or some customers in the loop if you're developing software for people as well. Should talk to each other and have feedbacks and the iteration. Don't forget what I said earlier on about AI and machine learning. And the same for anything you're doing in the development environment. There's always a question between the augmentation and the full-on automation. It's a spectrum. Sometimes towards one end's appropriate, sometimes the other end's appropriate. You need that sense of purpose, idea of what you're trying to achieve. And just get some feedback. See if it's what you really wanted. You can change from one to the other. Just think about what you're doing. And that's it, really. So what's machine learning got to do with it? Feedback, iteration, having fun, getting computers to play games, dystopian futures, sci-fi, I don't know. Feedback and iteration are the two main things. I've blazed through that, which leaves us some time for some questions. Stunned silence. I'll be around for the rest of the day if anyone wants to chat. But go and find out about machine learning. Try a framework or try and code something up yourself. And genetic algorithms are actually really as simple as that little for loop I showed you. And there's some sample code on the prog website where my book is. And you can download the code and play with it anyway. But you can do it yourself. Look up an algorithm on Wikipedia and try and implement it. Go learn. Have fun.
Thank you.
Thank you.